Welcome back to section 2.1.7. We're going to be talking about, is it a function or is it a sequence? Now we're talking about sequences. We use that notation T of n, and they are discrete, which means we are not connecting the points. That's why you see in that example, they're just dots, not connected with a line or a curve. Functions are continuous. You might see f of x, g of x, h of x, etc. Or you might even see a y. Functions are continuous. Sequences are discrete. Notice, once again, the difference in notation. If I say call it a sequence, you're going to use T of n. If I say use it a function, call it a function, f of x, g of x, and so forth. Now we have different types of sequences / functions. We're going to graph the following using a table of values. So identifying also the domain and range. This one is arithmetic / linear. Now for linear, let's kind of treat that as a y. But our slope is -1/2, and our y-intercept is at 0, 3. Now we could make a table of values, but for linear, we've graphed these a million times. We know we plot the y-intercept at 0, 3, and our slope is -1/2, which means you go down 1, to the right 2. Down 1 and to the right 2. And then you can draw your line through them. The reason we're going to be drawing a line is because it's a function, and functions are continuous. Now, our domain for this function. Our domain, we're going all the way left and all the way right, so it's all real numbers. Our range, since we're going all the way up and all the way down, that's also all real numbers. Now for additional practice, our x-intercept is going to be at 6, 0. You can see that right in the graph, and our y-intercept we already found is at 0, 3. Turning to the next page. This exponential. F of x equals 1/2 times 2 to the x. I'm going to make a table of values. -2, -1, 0, 1, 2, 3, 4. You can type this in your calculator if you'd like. When x is -2, we're going to be at 0.125. That's also 1/8. When x is -1, we're going to be at 0.25, which is 1/4. When x is 0, we're at 1/2. When x is 1, we're at 1, and then 2, 4, 8. Now these graphs have a horizontal asymptote. Exponentials have a horizontal asymptote, and this one is going to be at y equals 0. And because it's f of x, it's a function, we're going to sketch that with a curve, because it's continuous. Now, our domain is going to be all real numbers. We're going all the way left and all the way right. Our range, we're going from 0 and up, but we never reach 0, so y is greater than 0. Our x-intercept, we never reach the x-axis, so there is no x-intercept. Our y-intercept, it crosses that y-axis, and we can see at 0 and 1/2. And like I said earlier, we have a horizontal asymptote. At y equals 0. Next, we have a quadratic function, x squared minus 4. So we have -3, -2, -1, 0, 1, 2, 3. I'm just picking values around 0. If we need more, we can look at the calculator and find more. So if we type this in, -3, you get 5 as your output, 0, -1, you get -3, 0, you get -4, 1, -3, 2, 0, 3, -4. A lot of important information there. So we're at -3, we're at -5, -2, we're at, that's a +5. -2, we're at 0, then we're at -3, -4, and so forth. Now, because it's f of x, it's a function, it's continuous. There's our graph. Our domain goes all the way left and all the way right. It's all real numbers. Our range, though, we start at -4 and go up. So y is greater than or equal to -4, and that's because we reach -4. Our intercepts, if we look at the table or at the graph, we can see our x-intercepts. Remember, x-intercept is when y is 0. So we're at -2, 0, and +2, 0 for our x-intercepts. And our y-intercept, when x is 0, we're at 0, -4. And then finally, we have our square root function. You can use your calculator to come up with the table. When x is 2, I'm only going to pick the whole number of values. So we're at 2, 1, 3, 2, 6, 3, 11, 4. There's a whole bunch of other values, but I'm just picking the ones that are whole numbers to make it easier to graph. Over 2 up 1, over 3 up 2, 6, 3, 11, 4. We're off the graph. Now, the graph looks like this. You can't go past 2 because then we wouldn't be able to take the square root. So our domain, and it's continuous because it's a function, x is greater than or equal to 2, and our range, y is greater than or equal to y. Because of where this is, we never cross the x-axis, so there is no x-intercept. And for our y-intercept, there's also none. Keep in mind, arithmetic sequences are linear, geometric are exponential. Went over some other sequences and functions here as well. Sequences are discrete, we don't connect the dots. Functions are continuous, we do connect the dots. Okay, see you in the next one.